Okay, so this next unit is talking about atoms and the periodic table. I have these divided into two different note sets, so they'll be due on different days. This is the first part of it, and this is talking about the atom itself. Hopefully you guys have had some experience with these. Atoms are what elements are made of. So the elements on the periodic table all are made of atoms. So everything is made of atoms. And the atom is divided into three parts. It's protons, neutrons, and electrons. And we're going to go into each of those. Protons have a positive charge, and neutrons have a neutral charge. Hopefully it'll be easy for you to remember those. Proton, positive, they both start with P. Neutron, neutral, it has most of the word in it. So hopefully you'll be able to remember that pretty easily. These make up the nucleus. So they make up the center of the atom. What is on the outside of the atom are the electrons. The electrons they have the negative charge, so they balance out the protons. So in any given atom, in its normal state, will have the same number of electrons as it does protons. These travel around the nucleus, so they're creating a cloud is actually what the theory is nowadays. There's one called the Bohr model that we're going to use, and it's a model that just helps us conceptualize the levels of the electrons as opposed to how they actually travel. And so they're really more in like a cloud, so it's kind of a hot mess in there. Protons, all the elements have a specific number of protons. And so if I have carbon has 6 protons. If I change that number and I decrease it by 1 and I decrease it to 5 protons, then I now have boron. There is no way to have 5 protons and still be carbon. It identifies the element. It tells us what element it is. So anytime you're looking at the periodic table, I can pull out a random number. You can look at it and you can see, oh, that's such and such. Gold or silver or polonium or whatever it is that we're talking about. So protons are, the number of protons is also, it's equal to the atomic number. That's what we call it. That's what the number on the periodic table, we don't call it the proton number, we call it the atomic number. I don't know why. So protons and neutrons, you add those two together and you get the atomic mass. Like I said, the protons and the neutrons are making up the nucleus, and they're making up the bulk of the atom. Electrons are so small that they barely affect the mass. And so what we're looking at when we're looking at mass is protons and neutrons. So if we add them together, we can get the mass. So if you look in this equation right here, we're looking for the number of neutrons, and all we need to do is subtract the mass and the atomic number. So if I'm looking for the number for carbon, carbon has 6 protons, so its atomic number is 6. Its mass is 12, so you take 12 minus 6 and you get 6 neutrons. That's something that we're going to practice quite a bit in this class, is we're going to be figuring out how do we figure out the electrons, the protons, and the neutrons. So you're going to use that atomic mass and the atomic number to be able to figure out the neutrons. All you got to do is subtract. Simple math here, people. So electrons are equal to the number of protons. Like I said, they balance each other out. They make it so that the atom has a neutral charge. It doesn't have any charge once you take into account the protons and the electrons. So for carbon, it has 6 protons, it has 6 electrons. As you can see in the picture here, boron has 5 is the atomic number, so it has 5 protons and it has 5 electrons. And you can use this number right here, subtract it, 10.8 minus 5, roughly 5. This number that is given here is actually an average of all of the boron elements in nature, and so it ends up being a decimal, but I won't give you decimals like that. Like I said before, the electrons are so small they don't contribute to the mass, so they don't affect it when we're looking for neutrons. Okay, so as I mentioned, this is the Bohr model. I said this isn't technically correct. The electrons are not actually traveling around in just this single circle. They're more traveling around in a whole big mess, but they do have different levels. They have an energy level. And however many for each energy level, there's a certain number of electrons that can be in those levels. And so that is where the Bohr model helps us to conceptualize it, but isn't technically a correct representation of how electrons are moving. This is another view of it. You can see right here it has the nucleus, which has a positive charge because neutrons are neutral, but then they get balanced out by these electrons. And you can see that it says level 1, level 2, and level 3. So we'd be able to find how many electrons are at each level. Okay, so for our energy levels, and I want you to bear with me on here, I want you to get it down, and we'll really talk about this in class. So our first level can only ever have 2 electrons. When you see this right here, there are 2 electrons in here. Anytime that we're going to draw a Bohr model like this, 2 electrons is all that can be in the first level. So then, like for this carbon atom, there are 4 left after that. It has 6. We put 2 in the first level. 6 minus 2 is 4, so then we just stick those in the second level. The second level can only have 8 electrons. So once that second level right here, if we were looking at a different element, once it would be full, then we would have to move on to the third level. Third level can only have 18. The fourth level can only have 32. I am not probably going to get to the fourth level. We'll probably stick to the third level. Maybe if we want to do a slightly harder problem or do an extra credit problem, maybe that we'll do fourth level problems. But the outer level has the greatest effect on the properties. So how the elements are reacting with other elements, what their properties are, what they look like, stuff like that is all going to be affected, or the biggest contribution is going to be the outer level electrons, which are also called valence electrons. And valence electrons are actually, the periodic table is such a beautiful thing because it actually tells us how many valence electrons the elements have just by what column they're in, which is fantastic. You guys don't realize how much, like how well laid out the periodic table is and how much we can learn from it. So the outer level can never have any more than 8 electrons. And again, you bear with me. I'll get you there, okay? All right, so our symbols that when we use our elements for our elements, are our chemical symbols. The first level is always capitalized, and the second letter is, oh, did I say level? Anyway, first letter is capitalized, second letter is lowercase. The third letter, for some of them, have a third letter that's also lowercase. We're probably not really going to talk about those. Those are newer ones, and they're a little more obscure, and so we're really going to talk about ones like carbon and nitrogen and oxygen and gold and silver and, ones that you would recognize. So always first letter capitalized. I will take that into account when grading stuff. Okay, so isotopes are a little different, and again, I'm not really going to get into isotopes very much. You'll learn about that much more in high school chemistry if you choose to take it. So it's the same element, but it has a different number of neutrons. Remember back when I said you can't change the number of protons. That changes the element. But isotopes of the same element have the same number of protons, and they have a different number of neutrons. So that changes the atomic mass, which is where we get a decimal in the atomic masses because we have to take an average of them. So you look here, we have the isotopes of carbon. Carbon has 3 isotopes. It has carbon-12, carbon-13, and carbon-14. Notice the abundance right here, 98.9% of carbon in nature is carbon-12. This is the most stable form. It's the best one. We love it. Carbon-13 is about 1%, and then carbon-14, there's very, very little carbon-14. But we can use these isotopes, carbon-13 and 14, to be able to carbon date stuff, if you've ever heard that before, where we can figure out how old something is by the amount of carbon in it. And it's actually the carbon isotopes in it. And so the isotopes have the same number for protons. The atomic number is always 6. Notice that right here on our picture. But it is the mass that changes. It's 12 or 13 or 14. And all we do is we subtract those two to figure out the number of neutrons in there. It wouldn't affect the charge because, again, neutrons are neutral, so we'd have the same number of protons, so we would have the same number of electrons as well. You will learn later on that you can change the number of electrons, which will give you an ion, which will give you a charged element. So we're not really going to get into that, and just know that that's coming. And I think that's it for this presentation. Bye!